So today we're going to try and solidify your learning on the idea of metric and imperial systems of measurement. Okay. And what we're going to try and do is we're going to try and get you to understand how to convert something from metric to metric, and then from imperial to imperial, and then eventually be able to switch between the two different types of objects. Now, when you hear of the concept of a system of measurement, we're actually talking about the metric or imperial system, right? And we're actually looking at the length, the volume, mass, or the temperature of any object that we're talking about. When we talk about the metric system, we're talking about the system that most countries are using in the world, right? Canada and most other countries actually use this. Now, originally, this metric system was actually set up, or the idea of it was started somewhere in Europe. Usually, I believe it may have been in France, but don't quote me on that. Now, let's go and talk about the different kinds of types of units, base units for our metric system. Okay? Now, for our metric system, we have the following: length, volume, mass, and temperature. So those are all of the things that we're using. And for length, we're using the meter. And yes, we spell it M-E-T-R-E. And if you think about it, it's spelled the same way in French and in English. And you have to remember that French and English are the official languages of Canada. Now, for volume, we have liters. And we denote that base unit as the capital L. Now, for mass, our base unit is the gram, and that's denoted by the letter G, lower g. For temperature, we have degrees Celsius, and that's denoted by degrees C, capital C. So now let's move on to some key concepts that you'll have on your sheet. Hopefully you've printed this off, because you can use this base sheet as reference for when you're doing your practice homework. Okay. Now you'll notice that some of the commonly used units and conversions in the metric space are things that you've heard about before. You've heard about the millimeter, the centimeter, the kilometer, okay? And you've also heard about the liter, the kilogram, and the ton. Let's make sure we put T and put a emphasis on the fact that this is called a metric ton, okay? Now, 1 centimeter is equal to 10 millimeters, and we're going to use all these different equivalences in order to come up with the appropriate number for a translation of one distance into another. All right, so let's look at question number 1 here. They are asking us to translate 450 centimeters for a wall into meters, so we can use that and possibly go and buy that number of meters from some shop somewhere, okay? Or maybe they're using it to figure out how long a couch is, all right? Now, when we're doing that, we got to use the length that has centimeters and meters in it. So when we're looking at our length portion of our chart here, we have a length that has centimeters and meters in it. Yes, so 100 centimeters is equal to 1 meter. So we'll take a moment, write that down. So we're using the fact that 100 centimeters is being translated into 1 meter. Now, we got to figure out exactly what's happening here. Are we multiplying or dividing to get 1? So in essence, we're actually dividing by 100. So we're taking 100 centimeters and dividing by 100 to get 1 meter. So that means we have the following for this relationship that we have here. We're going to have 450 centimeters being translated into blank meters. Now, all we're going to do is use the same ratio or multiple or division that we've got. Now, we went and divided by 100, so we're going to divide by 100 here. Dividing by 100, and you end up with 4.5 meters as your final answer. Now, let's move on to the next question. Now, remember, we're always going to be referring to this sheet for length, volume, or mass to kind of help us change information from one thing to another. Okay? All right. So let's go back and look at this next problem. So if a container has a volume of 2.6 liters, what's the volume in milliliters? So here's what we want. In this case, we want liters is translated into a certain number of milliliters. All right, so let's go and do that. Let's go and look at our volume section of our chart. Now, in our volume section, you'll notice that our liters, for 1 liter, we produce 1,000 milliliters. Okay. Now, in order to go from 1 liter to 1,000, since it's a bigger number, we got to just times it. And in order to figure out that number, we say 1,000 divided by 100, and that will tell us that we're actually going to times by 1,000. So now, that's it. That's all we got to do. So now, when we look at our problem, we're saying we want to change 2.6 liters into milliliters. So let's do that. All right, so we want 2.6 liters is going to be translated into this many milliliters. And we're going to use the same operation that we did on that previous equation. So that means we are saying that we're going to take 2.6 and times it by 1,000, which will give us 2,600 milliliters as our final answer. So now let's move on to part 3 of our lesson. So sometimes we have to match the appropriate measurement with what we're looking for in our problems. So in this case, consider the examples of objects that need to be measured. Match the examples with the most appropriate unit by drawing lines between them. So pause the video and then try to match them, and then I'll show what the answers are for each of these. All right, here we go. So for the volume of a cooler, we're looking for about something in liters, because if you think about it, it's got to have a lot of stuff in it, right? The mass of an average person is going to be 75 kilograms. The temperature inside of a room, we're going to use, let's use blue this time. So now that means we've got, boom, 22 degrees Celsius. The thickness of a magazine. So it's either 170 centimeters or 10 millimeters. When you think of a magazine, the thickness of a magazine, you're not thinking that a magazine is very thick. It's usually less than less than a centimeter. And 1 centimeter is equal to 10 millimeters. So I'm thinking that this is 10 centimeters. All right, now the height of an average person is going to be 170 centimeters, and the distance around a track is 400 meters. All right, so now let's move on to the imperial system, and we'll work on dealing with stuff in the imperial system, just like we did at the very beginning of this lesson. All right, so some other countries in the world, particularly the United States, use a system of measurement called the imperial system. So this is something that was based in medieval times. And yes, it was used for many years. The only problem was at the time, a foot in one kingdom was different than a foot in another kingdom, right? And that's why they came up with the metric system all those years later. It was all done in order to facilitate trade between countries and have shop owners not lose money or rip other people off. Okay, that's basically why we ended up with the metric system. And now, since they've standardized the imperial system over time, yes, people use it, but not as much people use it because when they came out with the metric system, it spread like wildfire. But still, the United States chooses to use the imperial system. Now, because Canada has a large main border, right? And the system, the imperial system, is not recognized as a system of measurement, it's still important for us to know because the Americans are our neighbors, right? And the reason why we use it is the reason why we use the imperial system in business is because of this. And the reason why we do this is because we trade with the US all the time. But sometimes you end up having to buy stuff from other countries, right? And some of those countries actually use imperial system, and that's fine. It's just on you to figure out how much of the stuff you're trying to buy or what length of material that you're trying to get, things like that, or how much volume of a thing that you're looking for in imperial. That's all on you. So let's go over the basic units of the imperial system. And once we come up with the basic units, we'll come up with some other examples that are considered these things that we don't normally use. Okay? So the basic length that I know of in imperial is feet. For volume, I tend to recognize the gallon because that's usually what we're talking about when we're looking for a gallon of milk or a couple gallons of gas to get to work. All right, for mass, you've heard of this one, pounds. Yes. And for temperature, we have degrees Fahrenheit. Okay. Now, let's just put degrees F for Fahrenheit. Okay. Now, the other kinds of lengths that we have in in Imperial are miles and inches. We also have, along with gallons, we have quarts and fluid ounces. We have pounds and ounces as well for mass. Okay? All right. So now I want you to familiarize yourself with this, or at least have this little chart ready anytime we're going to do any calculations for our problem sets. Okay? So now, this problem here, let's just go over all of the points here. All right, so there's 12 inches for every foot, 3 feet for 1 yard, 1,760 yards for 1 mile. I need you to kind of remember that. That's something that everybody tends to forget. All right, there's 16 fluid ounces in a pint, 2 pints in a quart, 8 pints in a gallon, 16 ounces in 1 pound, and 2,000 pounds in 1 ton. In 1 metric ton. Sorry, in 1 ton from the US. Sorry. All right, so now this problem here is asking us to take something that is 144 inches long and change it into feet. So it says, if a wall is measured to be 144 inches long, what is its measurement in feet? So we got to go and look at our chart and determine which ones we're using. So we're looking for something that goes from inches, yes, to feet. Okay, so, all right, so how many inches? So there's 12 inches for every 1 foot. And in order to go from 12 to 1, we're actually going to be dividing, right? Because it's a lower number, and we're dividing by 12. So that means we've got 144 inches is going to be turned into blank feet. Okay. And we're going to use the same number that we used to change the previous ratio. So we're going to divide 144 by 12, and we're going to end up with 12 feet. And we're done. For question number 5, what we have to do is we're going to take a look at a container, right? And we're going to go and take 6 quarts, and we're going to turn it into a pint, okay? So let's go and write quart as QRT. So we want to know how many quarts is equal to a pint. All right, so when we look at our chart from before, you're going to notice that you're going to have 1 quart is equal to 2 pints. Okay? Which means when I go from quarts to pints, we're dividing, we're timesing by 2 to get 2 pints. So that means we're going to have 6 quarts goes to how many pints? Well, we're just going to multiply by 2 to get a final answer of 12 pints. All right, so now let's consider the following examples of objects that could be measured. All right, we're going to match the examples with the most appropriate measurement for each of these drawings. Okay, so we're talking about the volume of a cooler. right? Now, this one is going to be a little hard for a lot of us. If you think you know it already, pause the video and then I'll show you what my answers are. Okay, for the volume of the cooler, I think we're going to have about 5 gallons. For the mass of an average person, we're going to have about 175 pounds. For the temperature in a room, that's going to be 72 degrees Fahrenheit. Thickness of a magazine. Thickness of a magazine, or the height of an average person, is probably the easiest one to get right here. 5 foot 10 inches. Distance around a track, 200 yards. So a half inch would be the thickness of a magazine. All right, cool. So now we're going to work on converting between metric and imperial systems. Here we go. So these are the approximate conversions between the commonly used metric and imperial systems. Okay? Now, all of these equivalences can be used to help us find a distance in either imperial or metric, and we're going to use the same method that we used within each system to convert to the new system. Now, some of the more useful conversions that I've seen throughout my life are this one here, 30.48 to 1 foot, 2.54 to 1 inch, and 1.6K to 1 mile. Also, the volume for gas, you want to look at this. That one there is the most useful. And then for pounds, 0.454 kilograms is 1 pound. You could also say 2.2 pounds is approximately 1 kilogram. All right, on to question number 7. Now, for question number 7, we're looking at what would happen if a wall was to be measured, which is 14 feet long, and I want the measurement in centimeters. So here's what we know. So 1 foot goes to 30.48 centimeters, which means that we're taking 1 and multiplying by 30.48. So we're going to do the same process for the second thing that we're looking for. So we're looking for 14 feet changed into centimeters. So we have our setup, and then what we do is we say, all right, 14 times 30.48. And we end up with 426.72 centimeters for our answer. Now, let's see what happens when we do the same thing again, but this time we're going to do a volume translation, okay? So what we're going to do is we're going to turn 4 liters into gallons. So remember, 3.785 liters gives us 1 gallon. And we can write 1 gallon as 1 GAL. Then, what that tells us, in order to move from here to here, we have to divide by 3.785 to get 1 gallon. So now we're going to do the same for the second half of the problem, where we know we have 4 liters, and then we're going to divide it by 3.785 to get our volume in gallons. So we have something like this to start, and then we say that we're going to translate it. So we're going to divide both. We're going to divide it by 3.785 to end up with 1.06 gallons. All right, and so now we move on to question number 9. There are going to be 3 small charts that I'm going to create for you. All I want you to do is copy down what you see. So in the following graphing questions, right, you're going to be creating a conversion chart and then graphing the data, okay? So in order to graph the data, we have to know what each type of imperial to metric or metric to imperial conversion is. So in this case, when I'm looking at this problem here, where I want to convert inches to centimeters, we have to consider, well, going from inches to centimeters. So I'm just going to draw a little arrow underneath this. Inches to centimeters means that we're timesing by 2.54, right? So basically, for 1, 2, and 3, we get the following. And for number 2, we're going to get 2 times 2.54, which is 5.08. Then we end up with 3 inches turning into 7.62 centimeters. Now, in order to do the second half of the problems, that's this stuff here, you'll notice that everything is in centimeters. So what we have to do is we have to figure out what's going to happen when we go backwards. So going backwards, all we're doing is dividing by 2.54. So we take 12.7, divide by 2.54, and we get this. And we do the same again for 17.78, and you end up with 7. And then you end up with 50 for the last one. Now, when you graph this, you're going to get a graph, a rough graph that looks like this. It's very slanted, and its slope is centimeters to inches, which is, oh my goodness, 2.54 to 1. And we're done. All right, so now let's go and take a look at the next problem. The next problem is miles to kilometers. We'll do the same concept again. So going from miles to kilometers is multiplying by 1.6. So that means 1 becomes 1.6, 2 becomes 3.2, and 3 becomes 4.8. Just by multiplying those numbers by 3. Now, these other numbers that are already in kilometers have to be divided by 1.6. So we're going to do the same thing again. So we end up with, well, 10 divided by 1.6 is 6.25. Then you have 20 divided by 6.2 by 1.6 is 12.50 and 18.75. And we're done. Now, to graph this, when you go and graph this on Desmos or whatever, you're going to notice that your graph looks a lot like it's kilometers to miles. So for every 1.6, you're going to get something that looks like this, where m is equal to 1.6 over 1. Okay, that's it. Now let's move on to the last problem. Oh my goodness. So we have these 2 equations for Fahrenheit and Celsius. We will just use them to calculate each individual calculation, and then we'll graph it. Okay, so 0 gives us -18. negative 18. And I'll show you how you get that on your calculator. All right, so in order to get the Celsius, right? So if F equals 0, what you're going to do is you're going to type in C. Your C value is just going to be 5 divided by 9, and then bracket on your calculator, 0 minus 32, end bracket. And then hit equals, and you'll get minus 18. For the second one, if I'm looking for if the Celsius is equal to 0, I'm going to use a second equation, which is this one. So F is equal to, well, that's 9 divided by 5 times C. So that means because it's squished up, it's times C. And then we add 32. So that means that C that we have actually is a 0, which means this is, when you punch it in the calculator, 32. And you do the same thing again for 100, and you end up with 38, and then 68, and then 78.8, and 99.32. And that's just you spending the time punching in those calculations. Now, when we want to take a look at the graph that you're going to get, notice if the Celsius was 0, the height, the Fahrenheit was 32, right? And which one of those represents that? That's this equation here. So this equation is a line with a slope of 9/5. So, boom, there's our line, and there is our slope of 9/5. Because this is essentially the line y equals mx plus b. And we're done. Now, your homework is a worksheet that I prepared for you. It's a reduced worksheet as I want you to do a project for the end of this unit.